These are the review preview problems that go with 4.1.4 in the Algebra Connections book. So we'll start with 4-32. You're going to solve these two equations for x. So first thing I notice, I have some like terms I need to combine on both sides. So let's go ahead and do that. So I've got this minus 6 plus 1, which is going to be combined to minus 5. And then I have a minus 2x and a plus 5x, which will combine to be a positive 3x. So what I end up with is exactly the same thing on both sides. And what that means is no matter what value I put for x, they'll still be equal. So this one has infinite solutions. And when we get to b, let's use another color. Choose red. I don't have any like terms to combine on this side, but over here I have a bit of a mess to deal with. So let's do that first. Let's take care of this. So essentially what I'm going to do is I'm going to add these things instead, but I need to add the opposite. So it's like flipping from the negative to the positive on an expression mat. So instead of adding a positive x, I'm going to add a negative x. And instead of subtracting 1, I'm going to add 1. So then I have the rest of this. I still have the 2 minus 4x plus negative x plus 1. And on this side, I still have negative 2x minus 5. So now let's look at our like terms. I have, I'm subtracting 4x, and then I'm subtracting 1 more x. So that's going to be negative 5x. And then I have a 2 plus a 1, which will be a 3. So we end up with negative 2x minus 5 equals negative 5x plus 3. So let's move the x's over. So I'm going to add 5x to this to make it 0. Whatever I do on one side of equals, I have to do to the other. I'm essentially taking this negative 5x, I'm flipping it to make it a positive 5x. This becomes a positive 3x minus 5 equals 3. I'm going to add 5 to both sides. To make this 0, I have to keep the equation equal. So I have 3x equals 8. So x equals 8 divided by 3. So sorry, I skipped a step. Divide both sides by 3. Or you can put that into a mixed number. That would be 2 and 2/3. Moving on to the next problem, we have 4-33. I'm thinking of a number. So let's call that number n. I'm going to write this kind of in the middle. So if I have to add something to the front, I've got room to do that. When I double my number, that's going to be 2 times n. And then subtract the result from 5. So I'm taking this away from 5. So I started with 5, I subtracted 2 times the number, and I get negative 1 when I'm done. So that's the equation that we're working with. So what we're trying to do is figure out what number did you start with. So we will go ahead and undo everything that we've done. We subtracted this from 5, so we need to undo that. So we're going to subtract 5 from both sides. So I end up with, I'm still taking that away, and that's going to equal negative 6. And then I'm going to divide both sides by negative 2. And I get n equals negative 3. I want to make sure that I've got that right. So I'm going to double my number. So when I double negative 3, I get negative 6. I'm going to subtract that from 5. So 5 minus 6 is negative 1. So that is the correct answer. All right, moving on. This is 4-34. So we've got a table here. And what we want to do is explain in words what is done to the input value to get the output value. So what did I do to X to get Y? Luckily, I have that information right here. So what I did is I have my X and I multiplied it by 3. So I multiply X by 3. And then I subtract 2. All right, so if I want to fill in values, I would have 2. I multiply by 3, that gives me 6. Then subtract 2, I get 4. Only other X value I have is this -3. So let's go ahead and multiply -3 times 3. And then subtract 2. So that would be -9 minus 2, which would be -11. So -11 goes here. But then we need to figure out what did I start with to get 13. So what I know is that let's start with 13 here. So I had 3 times X. So I took X, I multiplied it by 3, then I subtracted 2, and I got 13. So this way, I have Y filled in. I don't know what X is, so I can solve for X. So we just go back to what we know about solving for equations. So I have 3x equals 15. I divide both sides by 3. And I get x equals 5. So if x equals 5, then I'm sorry, that is not what I wanted to write there. If x equals 5, if I multiply x by 3, I get 15, then subtract 2, I get 13. So you're just, you're writing an equation, you're still writing an equation, but what you're solving for is x instead of y. So I just substitute this number for y. This is my one side of my equation, this is the other side of the equation, and I solve for x. This next problem, this is 435. We'll look at the XY table. Invent a tile pattern that fits this data. So the information I need for a tile pattern is how many I add each time. Not having luck talking and writing today. So I need to know growth. And I need to know what I started with. So that would be figure 0. And this would be number of tiles. Okay, so if these are the figure numbers. At figure 0, it says I have 5 tiles. So that's how you start your pattern, is you make a figure with 5 tiles. And then the growth is 4 tiles. Because if you see here, this goes up by 4. This goes up by 4. Goes up by 4. So I'm adding 4 tiles each time. So what you'll do is you'll build a pattern that starts with 5 and adds 4 as you go up by figure number. And then part B asks you to identify the growth factor, show where the growth factor appears in the table, which we have done, and then show where it appears in the tile pattern. So when you make your tile pattern, show where that growth is. All right, this is the last problem. This is 436. We're looking at the graph. What statements can we make about the tile pattern that the graph represents? So this represents a tile pattern. So here's what we know. We know that figure 0, we can say how many are in each figure. Figure 0 is the important one for the equation. Figure 0 is along the y-axis. This is 6, this is 8. So in between where this point is, that would be 7. So figure 0 has 7 tiles. And in a table, if I were building a table, that would be figure number 0, and that would be 7 tiles. So the other thing we want to know is how it grows. So when I go over 1, so this is +1 here. So as I go up in my figure number, how many tiles does it go up? So this goes from 7 to 11. So that goes up 4 tiles. So as I go up figure numbers, the number of tiles goes up 4. So if I want to add 4 over here, then that next figure would have 11 tiles. So the growth is 4. So just to take this to the next step, if I wanted to write an equation for this, my growth is 4, so that's m, so 4x. And the figure 0 is 7, so it would be 4x plus 7 would be the equation for that.